Hi guys, so today we're going to cover the constant multiple rule and the sum and difference rule for derivatives. These are real easy. In the power rule, you might have seen me use them in the power rule section and maybe in the power rule tutorial. So I'm just going to go over these. They're real simple, nothing too complicated. So let's get started. The first one, the constant multiple rule, you've probably seen in class. It's fairly straightforward. So what it says is let f of x, let's say f of x be a function, and let c be a constant. Yes. So if you have, let's say, some function now, g of x, which is equal to c times f of x. So c is some constant, f of x is some function, and then g of x is just equal to, well, this whole thing. What this is saying is basically the derivative of c f of x is equal to c times the derivative of just f of x. Pretty easy. You've probably seen it. Not too hard. This is all it's saying is just that take the derivative of the function and then just multiply it by the constant, whatever that derivative may be. You just multiply it by the constant, right? So I'm gonna do a little proof using the limit definition of the derivative, so you can get a better sense of it, where it came from. So I'm gonna erase all this, except actually I'll erase that too. So I'm gonna bring back that g of x right now, because we're gonna need that. So g of x is equal to c some constant times f of x. So using the limit definition, let's prove the constant multiple rule. So the constant multiple rule again states that the derivative with respect to x here of c times f of x is equal to just c times the derivative of just f of x. So let's prove it using the limit definition of the derivative. So let's write down our definition, which is limit as h approaches 0. And in this case, we're gonna use g of x to represent this, and we're gonna say g of x plus h minus g of x. We're taking the derivative of g seemingly here, so all over h. And what we're gonna do now is then, in place of this and this, we're gonna sub in this. So we could have done this directly, but it's I guess this can help show you how it's done maybe a little clearer. So you're gonna sub this in, and so what do you get? So in place of g of x plus h, you're basically gonna get c times f of x plus h, and then obviously minus g of x is just minus c f of x, and this is all over h. Now you can see that I can factor out c, and I'm going to factor that out of the limit, and so what I'm basically left with is c times the limit as h approaches 0 of f of x plus h minus f of x all over h. And you realize that this expression right here is equal to f prime of x. Therefore, putting these two together, what you get is c times f prime of x, which is basically what we had here, the constant multiple rule, c times the derivative of f of x, and that's what we got here, c times f prime of x. Cool. So let's do an example. So let's say f of x is equal to, let's say x to the 9, and let's say c is equal to 8. And so let's say our g of x is 8x to the 9. So let's find the derivative of this. So what we're going to get is, well, our f of x is this part and our c is this part. So what we're going to get is obviously c times f of x, f prime of x, which is then equal to 8 times, now we're taking the derivative of the function right here, x to the 9. Bring down the 9, and we got what? 9 minus 1. This is 72 x to the 8. That's our answer. So what you see here is that the constant multiple rule is really simple, and that you don't always, have to write it down like, g of x is equal to these two things. After a while, actually fairly quickly, you'll just be able to go directly to the answer just by, just taking the derivative of f of x and just knowing that, this is a constant. You can just directly go from there. I was just doing a little more explanation using the proof, but it's fairly simple. Our next rule is the sum rule. The sum rule is quite simple also, and what the sum rule is saying is, so you got these two functions, f of x and g of x, and they're both differentiable. So what the sum rule says is the derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x. And here it's with respect to x. So what it's saying is that if I sum these functions first, then take the derivative, it is the same as taking the derivative of each term, or each function on its own, and adding it together. Not too complicated, pretty easy. I'm going to do a little proof of why this is the case. So I'm going to erase this. Keep this in mind though. Just going to write this again somewhere on the top. So again, we got our f of x and g of x. Actually, I'm just going to write the rule. So we got our f of x and our g of x. So our rule states, the sum rule states that the derivative of the sum of these two functions is equal to the derivative of each function on its own and then added together. Okay, so let's use our limit definition, but before we start, we got these two functions, and we're going to say big F of x, capital F of x is small f of x plus small g of x. And we're going to use our limit definition. So we're going to say limit as h approaches 0 is of big F of x plus h minus big F of x all over h. We're going to do the same thing we did for the constant multiple. We're going to do something like that. We're going to sub this in, right? So what are we going to get? We're going to get a limit as h approaches 0, and we're going to get f of x plus h plus g of x plus h. And now that's this part. So now we gotta sub in this part, and we know that big F of x is equal to small f of x plus g of x. And that means that minus, we're gonna put these brackets here, f of x plus g of x. Notice that you have to distribute this negative sign before you do anything, so make sure of that. Don't make that mistake. You're going to end up actually subtracting g of x, not adding it. So after you distribute this negative sign. So let's continue. So what do we have? We get our limit as h approaches 0 of f of x, f of x plus h plus g of x plus h minus f of x. Oh yeah, you gotta distribute the negative sign here too. It's gonna be minus f of x and minus g of x all over h. Now notice something. We can group the f of x terms, the f of x plus h and g of x plus h and the g of x terms together, and we will get the limit as h approaches 0 of f of x plus h minus f of x plus g of x plus h minus g of x. Put this all over h. And what we can do now is split this limit into two parts. So we can now say that the limit as h approaches 0 of f of x plus h minus f of x all over h, that's one part, and then we can say plus limit as h approaches 0 of g of x plus h minus g of x all over h. So we can split this in two, and you can see that that is correct. You split this into two, and what does this tell us? Well, this tells us, what does this represent? This is just f prime of x, and what's this? This is just g prime of x. So what does this become? This is just f prime of x plus g prime of x. So there we go. We got the sum rule out of that. So that's pretty cool. Using the limit definition of the derivative, we found the sum rule. So let's do an example. So let's say we have some function f of x, and that is equal to x cubed plus 5 over x plus 6x. So we got multiple terms here. So what we're going to do, we take the derivative of each term and we add it together. Obviously, we just take the derivative of each term separately. So the derivative of this, the derivative of this, and then the derivative of this. That's what the sum rule is basically saying. So let's see that in action. But just to go slowly, since we are still doing pretty easy stuff, I will do something, I guess I will go through this a little slower. So what I'm going to do is actually I'm going to rewrite this as x cubed plus 5x to the negative 1 plus 6x. So it's easier for you to see how I took the derivative. So what is my f prime of x? Well, f prime of x, let's take the derivative of the first term, which is x cubed. The derivative of that is 3x squared. So we got our first term down. Now our second term, what is our derivative? Well, you know, we did this in our other videos. So basically, obviously, just like the first term, bring down the 1. So we got negative 5. So we got plus negative 5 x to the negative 2. And then we did that. So our last term, which is just 6x, and the derivative of that is just 6. And simplifying this, what we got 3x squared minus 5 over x squared plus 6. There we go. That's our derivative of this function. So let's continue on. The difference rule is just, okay, I'm going to write down the difference rule actually. And the difference rule is basically just the sum rule, but with a minus sign. So recall the sum rule was just saying that the derivative of these two functions f and g of x, the sum of them, taking the derivative of the sum, is just equal to the derivative of each function on its own and then summed up together. So this is what it said. What the difference rule says, what it says is the derivative, we still got our f and g. Now it's f of x minus g of x. It's just a sign change. Is just equal to the derivative of f of x minus the derivative of g of x. There's no difference. It's just a sign change. So I'm not going to go through the limit definition of the derivative and drive this rule because it's just a sign change. It's nothing big. So if you got two functions, one subtracting the other, basically the rule is almost the same as the sum rule. It's just that you have this minus sign. So let's do an example. So let's say f of x is equal to, let's say it's equal to negative x to the 5 minus 4x minus 9 to the x. So got this subtraction, and so what's the derivative? Let's simplify it a little bit. So we got negative x to the 5 minus 4x minus 9x to the negative 1. So let's take the derivative. So the first term is just negative 5x to the 4. And now we got the subtraction of 4x. So it's the same thing. You just take the derivative of each term on its own. Same thing as the sum rule. Each term, just take the derivative of each term. So what's the derivative of 4x? Well, it's 4, and we got this minus sign, so it's minus 4. And let's take the derivative of the last term. Well, what's that? We got minus, and bring down the 1, we got negative 9x to the negative 2. So simplifying this, just take the derivative of each term, negative 5x to the 4 minus 4. And since we have minus negative 9x to the negative 2, this is going to be plus 9 over x squared. Okay, so as you see, the constant multiple rule and the sum and difference rule are fairly easy. There's nothing complicated about them. It's just that, for the sum and difference rule, all you're doing is you're just going to take if you have this addition, these bunch of terms, you just take the derivative of each term on its own. That's it. And then add them together. That's all. Or, yeah. So that's all you're really doing when it comes to the sum and difference rule. It's nothing special. It probably seems kind of intuitive. So, and the constant multiple rule, that is very, very simple. It's just you have some constants, so you just multiply by the derivative.